This is going to be a quick video on p-series. So a p-series is another special kind of series, kind of like a geometric, except it's in the form of 1 over n to the p, where p can be any value. And to figure out when this series converges, we're going to use the integral test. So our function is 1 over x to the p. We're integrating from 1 to infinity of 1 over x to the p dx. I'm going to begin by writing this as x to the negative p and making the integral proper with the limit, like so. And using the power rule, we get this, which we can rewrite as this. And now we're going to evaluate from 1 to b, like so. Now that we've arrived at this, we're going to test 3 possible cases of p to see whether the integral converges. And by the way, when we're evaluating the cases, we can just disregard this because it's a constant. So the first case, if p is less than 1, then this in the exponent here is greater than 0, which means b stays on the top. And if b stays on the top, then as b goes to infinity, the top will go to infinity, so the integral diverges if p is less than 1. In the second case, when p is greater than 1, notice that this result now becomes negative, which means the exponent can go to the denominator, like so. And in this case, when b goes to infinity, this goes to 1 over infinity, which goes to 0, and thus the integral converges when p is greater than 1. And lastly, if p equals 1, then we have to evaluate the integral from 1 to infinity of 1 over x dx, which we know is infinity. So from this analysis, we can see that when p is less than or equal to 1, the integral diverges. But when p is greater than 1, the integral converges. So by the integral test, this series must have the same behavior. That's how you determine the convergence of a p-series. And there's a more special type of series called a harmonic series, which is in this form where a and b are constants. In reality, a harmonic series is just a p-series when p equals 1 with a few extra things added. But those things don't make a difference, and so all harmonic series diverge. This is a special type of series that you can use a shortcut for. To close the video, we're going to determine the convergence of the following series. For the first one, I'm going to start by taking the 4 out of the sum, like so, and now I'm going to combine n and root n, like so. Now it's in the form of a p-series, and p is 3 halves. Since 3 halves is greater than 1, this series converges. For the second one, like the last one, I'm going to start by taking the 11 out of the sum, like so, and now I'm going to rewrite the radical, like so. And here it's in the form of a p-series, and we can see that p is 1/5, but 1/5 is less than 1, so this series diverges. Now we have the series of 6 over 3n plus 2, and like the last two, I'm going to start by taking the 6 out of the sum, like so. And this should look familiar because this is a harmonic series where a equals 3 and b equals 2. But it doesn't matter what a and b are equal to because all harmonic series diverge. And that's how you find the convergence of p-series.